All right, we will be discussing the word problems of exercise 6.5. So we'll start with question number 17. Question number 17 says, a square piece of tin of side 18 centimeter is to be made into a box without top. So we have a square piece of tin. So since it is a square, so all the sides will be equal. So if this is 18 centimeter, this will also be 18 centimeter. A square piece of tin of side 18 centimeter is to be made into a box without top by cutting a square from each corner. So we have to cut a square from each corner. After cutting a square from each corner and folding up the flaps to form a box. तो अब हम इससे एक बॉक्स बनाएंगे. तो बॉक्स बनेगा, it means that will be a cuboid. What should be the side of the square to be cut off? तो ये जो कॉर्नर से हमने स्क्वायर्स कट किए हैं, they are asking what should be the side of the square to be cut off. So let the side of the square to be cut off be x centimeter. Let the side of the square to be cut off from the corners, to be cut off be x centimeter. So let the side of the square to be cut off be x centimeter. Question is, what should be the side of the square to be cut off so that the volume of the box is maximum possible? Means we need to maximize the volume of the box. Now, volume of the box is given by L into B into H. Length into breadth into height. Now, we will first see what is the length of this cuboid. Now, the portion, this portion will be the length of the box. This portion will be the breadth of the box. Why? Because we have cut down various squares from the corners and the side of the square is x. So we can say that the length of this box will be 18 minus 2x, because we will subtract this x and this x because we will fold it to form a box. Now, similarly, the breadth will also be the same. The breadth of the box will be 18 minus 2x. Now we'll talk about the height of the box. Height. हमने साइड से एक सेंटीमीटर के कॉर्नर्स कट किए और उसको फोल्ड कर दिया. इसका मतलब जो हमारा बॉक्स है वो सिर्फ एक सेंटीमीटर रेज हो जाएगा. So we can say that the height of the box is x centimeter. So volume is given by 18 minus 2x length into breadth into height. So my volume is 18 minus 2x ka whole square into x. Question is, what should be the side of the square to be cut off so that the volume of the box is the maximum possible? That means we need to maximize the volume of the box. We have to make sure that whatever function we are maximizing or minimizing, that should be a function in the single variable. Now, in this case, volume is given by 18 minus 2x ka whole square into x. So, volume is a single variable function which is in terms of x. So, now we will apply the double derivative test to find out the maximum volume. Now, first of all, what is the second derivative test? Now, second derivative test is, you take a function f of x, you find out its derivative, equate it equal to 0. Suppose you get some critical points, then you find out the double derivative at those points. If the double derivative at a particular point is negative, then we say that x1 is maximum and f of x1 is the maximum value. Now, if the double derivative at a particular point is positive, then we will write that x2 is the minima and f of x2 is the minimum value. So this is how we are going to apply the second derivative test to find out the maximum or the minimum value of a function. Now we'll move back to our question. The question was that we need to find out the maximum volume of the box. Now volume is given by 18 minus 2x ka whole square into x. Now we are going to apply the second derivative test. So we will find out dv by dx. There are two ways to find out dv by dx. The first way is that you apply the product test, the product rule. And the second way is that open it and then differentiate it. We are going to apply the product rule. So u is 18 minus 2x ka whole square. So u dash will be twice of 18 minus 2x. And then the differentiation of 18 minus 2x, which is minus 2. So u dash is minus 4 into 18 minus 2x. Now v will be x and v dash will be 1. So we are going to apply the product rule to find out the derivative. So dv by dx will be uv dash plus vu dash. So u is 18 minus 2x ka whole square into v dash is 1 plus v is x into u dash is minus 4, 18 minus 2. Now we are going to take out 18 minus 2x common so that inside the bracket we are left with 18 minus 2x minus 4x. So the two factors that we got are 18 minus 2x and 18 minus 6x. So the first step of the second derivative test is equate it equal to 0 to find the values of x. Now if we equate them equal to 0, we will get two values of x. X equal to 9 and x equal to 3. Eighteen minus 2x equal to 0, 2x equal to 18, and value of x will be 9. And another factor was 18 minus 6x equal to 0. So 6x is equal to 18. The value of x is 3. We have got two values of x. Now, first of all, we'll see that what was our length. Our length was 18 minus 2x. Our breadth was 18 minus 2x. And our height was x. If the value of x is 9, then our length will become 0. So we are automatically going to reject that value. So x equal to 9 is rejected. Why is rejected? Because if x is equal to 9, then length will become 0 and breadth will also become 0, which is not possible. So that is the reason we are going to reject x equal to 9. And for x equal to 3, we are going to check whether that is giving me the maximum volume or not. So for that, I need to apply the second derivative test. My dv by dx was 18 minus 2x and 18 minus 6x. Now again, I'm going to differentiate it by using the product rule to find out the second order derivative. So in this case, my u is 18 minus 2x. My v is 18 minus 6x. So u dash will be minus 2. V dash will be minus 6. So my double derivative d2v by dx2 will be uv dash. So that is 18 minus 2x into minus 6 plus vu dash, that is 18 minus 6x into minus 2. Now I'm just going to put x equal to 3 to find out the sign of the double derivative. So if I put x equal to 3, so this will be 18 minus 6, which is 12 into minus 6 plus 18 minus 18, 0. So this is minus 12 into 6. Without calculating it, I can write that this is less than 0. And since the double derivative is less than 0, this implies volume is maximum at x equal to 3. So the question was, find the side of the square to be cut off so that the volume is maximum. So the side of the square to be cut off should be 3 centimeter. Now, if we look at question number 18, if we look at question number 18 of exercise 6.5, now this is very similar to what we did in question 17. In question 18, it has been given that there is a rectangular sheet. There is a rectangular sheet of tin 45 centimeter by 25 centimeter, 45 by 24. Whenever it is given this by this, it means this is our length and this is our breadth. This is a rectangle where length is 45 centimeter, breadth is 24 centimeter. Again, they are saying the same thing, that from this rectangular sheet, a box is to be made without top by cutting off the square from each corner and folding up the flap. So we are going to apply the same method which we did in the last question. What should be the side of the square to be cut off so that the volume of the box is maximum? Now, volume of the box is given by L into B into H. Now, in this case, our L will be 45 minus 2x. Our breadth will be 24 minus 2x and our height will be x. So the volume of the box will be 45 minus 2x into 24 minus 2x into x. Now, we are going to apply the same method. We will find out dv by dx. We will equate it equal to 0, find out the possible values of x, and then find out the double derivative. But in this case, what we can do is we can take 1x inside the bracket. So this will become 45 minus 2x into 24x minus 2x square. And now we can apply the product rule to differentiate this. So if we apply product rule, my u will be 45 minus 2x and my v will be 24x minus 2x square. So du by dx will be minus 2 and dv by dx will be 24 minus 4x. So dv by dx, I'm going to apply the product rule, ub dash plus vu dash. So 45 minus 2x into 24 minus 4x minus 2, 24x minus 2x square. Now I am not going to get anything common out of it. I can just get 2 common or 4 common. That's it. So what I need to do is, in these type of questions, try to take out maximum things common. From here, I can take 4 common and it is going to give me 6 minus x. And from here, I can take out 2, so 2 into 2, 4. And this is going to give me this is going to give me 12x minus x square. So overall, I can take out 4 common. Now, whatever is left, I'm going to open it and solve. 270 minus 12x minus 45x plus 2x square minus 12x plus x square. So when I will simplify this, I'll get a quadratic equation in x. Then on this quadratic equation, I'll apply splitting the middle term to find out all the possible values of x. And then accordingly, I'll apply the second derivative test to find out the maximum volume. So if I simplify this, this is going to give me 2 plus 1, 3x square. Then minus 12, minus 45 and minus 12. 24 plus 45. Minus 69x plus 270. This is my dv by dx. Before equating it equal to 0, first I need to see whether there is anything which is again coming out common or not. I can take out 3 common. So this is going to give me 12 x square minus 23x plus 9. Now I'll equate it equal to 0. I have to apply splitting the middle term. Splitting the middle term, sum should be minus 23 and product should be 9. So I need to find out two numbers whose sum is minus 23 and product is 90. So in order to find it out, I'll take out the prime factorization of 90. 15 and 6 is going to give me 21, but I need 23. So I have to look out for some other factors. 10 and 9 is going to give me 19. So I have to look out for another factor. 3 into 3, 9, 9 into 2, 18. 18 and 5 will give me 23. So I can take my factors as minus 18 and minus 5. So x square minus 18x minus 5x plus 90, and I'm going to equate it equal to 0. So my factors are going to be x minus 18 and x minus 5. I can clearly see that my factors are x minus 18 and x minus 5 equated equal to 0. I'll get two possible values of x, 18 and 5. Now which value to be continued? So for that I need to again look at what was my length and what was my breadth. So I'm going to keep two things. First of all, dv by dx, which was this, because I need to differentiate it again. And then I need to remember the two values of x which I have got. So x is equal to 18 and 5. These are the two values. My length was 45 minus 2x. And my breadth was 24 minus 2x. Now I have to see that if I put x is equal to 18 in this, then my breadth will become negative, which is rejected. So I'll write if x is equal to 18, breadth will be negative. Therefore, we are going to reject x equal to 18. So x equal to 18 is going to be rejected. So my only value is x equal to 5, which I need to check is giving me the maximum value of volume or not. So dv by dx was this. So now again, I need to double differentiate it. So this will give me 2x minus 23. If I put x equal to 5, so this is going to give me 10 minus 23. Without calculating, you can just get a sense of positive or negative sign. And then just write that this, since this is negative, therefore volume is maximum at x equal to 5. And x equal to 5 will be your answer. Question number 19. Question number 19 says, show that of all the rectangles, inscribed in a given fixed circle, show that of all the rectangles inscribed in a given fixed circle, square has the maximum area. In the word problem of chapter 6, we need to remind two things. First thing, we need to be very clear from the question what is given to us and what we need to maximize or minimize. whatever is given to us in question, whatever is given to us, that become a constant. And we need to be very clear as to what needs to be maximized or minimized. So if it has been given that the length of the, if it has been given that the length of the radius of the circle is r, that means r is a constant. I should treat r as a constant in my entire question. So whatever has been given in the question, it means that has been, that should be treated as a constant. Another thing, if it has been given that the figure is given, it is a circle, it is a fixed circle. It means whatever is the dimension of the circle, that is a constant. So radius will be constant in that case. Next thing that we need to remember is that whatever we need to maximize or minimize should be into a single variable. The function